69%. Look at these numbers. All of them, at least 62%, said they had failed to replicate or reproduce the results from somebody else's experiment. Now, I want to point out that when we say experiment here, in our field, we're generally talking about human subject experiments. But in many of these other fields, we're talking about experimental results that don't necessarily involve human subjects, such as in chemistry or physics and engineering and so forth. In my own lab, we had a situation where we could not successfully replicate an algorithm that was reported in a previous paper, for example. We couldn't get the algorithm to work the same way. So replication, the issue of replication goes beyond human subject experiments. Any thoughts about this?
There is a question and answer, but nothing why to go there.
Oh, okay. So there's a Q&A in Zoom, but we can't get to it. I don't know how to get to it. Arif and I'll work on getting to that.
There's actually a question by Bill Bernstein. I don't know if I can read it out.
Where is it? Oh, I see it now. Sorry, this is so long, I can't really read it and summarize it. Maybe Jens, you can think about it and bring it up.
Well, the basic question, as I get it, does replication help? Would replication help? And more data help?
Yes. So for the rest of this tutorial, part of it's going to be about the specific ways in which replication does help. So I think the answer is yes, it does. So here's another way. In fact, this very slide is the importance of replication. Okay, so here's another way of expressing the importance of replication for scientific progress. Now later, in a moment in this slide, it's going to be the only time that I play a video where I want the sound to be heard. I think this will work. If not, I'll just talk about it over that part of the slide. Okay, so a long time ago, about 3,500 BC, Aristotle sought to explain observed natural phenomena, such as why do objects fall to the earth? Aristotle noticed that light objects, such as a feather, fall more slowly than heavy objects, such as a rock. Now, I want to point out that the idea that this was a rock and a feather is apocryphal. We don't know if Aristotle was actually influenced by a rock and a feather, but Aristotle did report this observation. At the time, of course, there was no tradition or history of experimental science. Aristotle concluded that heavier objects fall faster than lighter objects. In today's knowledge, he concluded that acceleration is proportional to mass. Today, we know that this is wrong. Aristotle did not consider air resistance, but this was the accepted theory for 2,000 years. This was the accepted scientific theory. So 2,000 years later, in about 1600 AD, Galileo tested Aristotle's theory by dropping things from the Tower of Pisa in Italy, no less. And among the things he dropped were a cannonball and a musket ball. So the musket ball is the small ball and the cannonball is the big ball. And the important thing is that both of these objects are made of similar material, iron, and they're similar shapes. So they would have similar air resistance. They're also very dense. And so air resistance would not have that much of an effect on objects this dense. Now, this is also somewhat apocryphal in that we don't know exactly if this is what Galileo dropped, and we don't know exactly if Pisa is where he dropped them. But he did drop things from heights. And he saw that the musket ball and the cannonball fell at the same rate. He correctly concluded that objects fall at the same rate, that is, a constant acceleration according to the gravitational field. This is an example of the power of replicating a known experiment, and in this case, coming up with a different answer. So now, and this is the part where there's going to be a little video. In 1971, Apollo 15 was on the moon. 1971 is the last time that, or maybe it was 1972. Anyway, it was around the last time that humans walked on the moon. David Scott was the name of the astronaut who was the commander of the Apollo 15 mission. And at the end of the last moonwalk, he dropped a feather and a hammer. He dropped a falcon feather because this lunar module was named the Falcon. And so I'm going to show you a video of him doing this. The moon has about 1/6 the gravity of the Earth. So you'll notice that the hammer falls more slowly than it would on the Earth.
Well, in my left hand, I have a feather. In my right hand, a hammer. I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago, who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that?
Okay, so that's pretty hard to see. It's low resolution in terms of today's video, but he's on the moon and he drops a hammer and a feather and they fall at the same rate and hit the ground at the same time. Of course, the moon has no air, so there is no air resistance. And one thing that I think is striking is he says, one of the reasons that we got here today, one of the reasons that it was possible by the 1960s to send humans to the moon where they could walk around, survive, and come back was the scientific process. There's no way that that would have been possible without the scientific process. And so, you know, the continuing development of knowledge and replication is part of that development of knowledge. So that's an introduction to the replication crisis. Is there anything else about that question?
Not yet.
Okay. All right. So now we're going to talk about a specific project, the reproducibility project in psychology. And I already mentioned that the reason for this project was it was inspired by this inability of so many cancer drugs to replicate. So we're going to talk about this reproducibility project in psychology. This project was begun by this fellow, Brian Nosek. He is a professor of psychology at the University of Virginia. And he produced a paper that I will briefly show you now. And so this is the paper that came out of the reproducibility project, estimating the reproducibility of psychological science. So this paper is what inspired this tutorial and the series of tutorials that I've given at previous meetings. It's a very good paper. It's very well written. I can't really recommend it too highly. So, and you can see I read it carefully. And I want to point out that the author of this paper is the Open Science Collaboration. What is the Open Science Collaboration? Here are all the members of the Open Science Collaboration. And one of the things that I think commends Brian Nosek's leadership of this project is that notice that his name is just one of the many names here listed alphabetically. So he didn't take first author. He didn't take any particular, author position. Every person who worked on replicating these experiments is a co-author. So that's a very interesting structure for a paper to have. Why did it start again? One's supposed to do that. Let me do something else. So, see, I wish this window wasn't here. Let's see, maybe I can make it go. Well, it's almost. Okay, now if I start from here, I think it'll behave better. Okay, so the final paper has 270 co-authors. Oh, that's a little better. Okay. So this project replicated 100 published studies. And the first question in the project was to figure out what studies should be replicated. The goal here was to minimize selection bias and maximize generalizability. So the team first published something they called the sampling frame, as well as the selection criteria. This is where they defined how they were going to choose the studies that were going to be replicated. So their replication efforts covered 3 leading journals. The Journal for Psychological Science, and in their field, that's considered the premier outlet for all psychological science. And then the Journal of Personality and Social Psychology, that's considered the leading journal in social psychology. And finally, the Journal of Experimental Psychology, Learning, Memory, and Cognition, and that's considered the leading journal for cognitive psychology. So the goal of these journals was to cover some of the main areas in psychological science. And so the sampling frame involved the first, beginning with the 2008 issue. At the time this was begun, that was an issue that was 3 years in the past. So the first 20 articles in each issue, and then 10 more articles if needed. And the goal was to replicate the last study in each article. And that's because the last experiment in an article is usually or often the experiment that is the most important or the main topic or point of the paper. many times the earlier experiments are more preliminary in nature. So 84% for the last study. And then the result of the experiment had to be a single inference test, either a t-test, an f-test, or an R correlation. Those were the three kinds of inference tests. And if available, the replication was going to use the original materials that were used in the first experiment. So that would be like if one of us published a paper with a certain head-mounted display, a few years later, a replicating team asks us to send them the same head-mounted display that we used. So original materials were used where possible, and design feedback from the original authors was sought. Finally, the replication, because the original experiment had an effect size that was known since it was a conducted experiment, the replication recruited enough participants for high statistical power. In particular, the power was the amount recommended by the power analysis literature of Jacob Cohen and so forth. So at least a power of 0.80. So this minimizes the probability of a type 2 error. So P equals 0.05 is designed to minimize the probability of a type 1 error. Power is the probability 1 minus the probability of a type 2 error. And so having a 1-to-4 ratio of these two errors is considered good experimental methodology, at least in psychology. So there were 488 articles in the 2008 issue of these three journals, and there were 158 that were selected by this replication scheme. And they selected 113 of them, and exactly 100 of these replications were completed by the deadline. So this is a nice round number, but it was an accidental accomplishment that they tried to replicate exactly 100 experiments. Think about the scope of this project. That's a huge number of experiments to replicate. And that's why there were 148 authors. Any thoughts or questions? Let's see. Go back to Discord. No. Okay. So the first question that they had to address was, how do we measure a replication? And how do we quantify a series of replications? So what does it mean to replicate a result? Each experiment was analyzed using a standard R package. So the authors developed software in R, and each analysis, each statistical analysis was performed by the replicating team, and then their data was sent to a second team, and the analysis was performed independently. So all the analyses were performed independently by two different teams using a standard set of R packages. So everyone used the same software. And the data was quantified along these dimensions. So the original study characteristics included the p-value of the final hypothesis test, one hypothesis test per experiment, a measurement of the effect size, either the sample size in participants or the degrees of freedom. If the experiment was a repeated measures experiment where individual participants provided more than one data point, then the degrees of freedom was higher than the sample size. Then The importance of the result was rated by all of the participants. I mean, by all of the authors, the replicating authors. So how important was this result of the original study? How surprising was this result? Were you surprised to hear about this? And how experienced is the original team, and what is their expertise? So all of these characteristics were measured for the original studies. For the replication studies, these also had p-values, effect sizes, power. There was a challenge. How challenging was the replication? That was rated. What is the experience and expertise of the replicating team? And what is the quality of the replication? So all of these characteristics were gathered about the replication experiments. So now I'm going to present the results. And the results can be looked at in several different ways. So here we have all the original studies to the left and all of the replication studies to the right. Here we have the p-value of the replicated experiment. So the p-value, of course, goes from 0 to a high of 1. And this dashed line here is the 0.05 level. So these are violin plots. So a violin plot is like taking the distribution of the y value and then reflecting it so it's symmetrical. So it gives you a visual sense of the distribution of p-values. The dot here is the median p-value. And then the quartiles are also indicated. So here we see the first quartile is basically invisible because the p-values are so low. But the second quartile is here, here's the third quartile, and here's the fourth quartile. So for the original studies, the p-value is below 0.05 for 96 out of these 100 values. For 4, the p-value was 0.06, but the paper treated that as a significant effect. So there are several different statistical ways of comparing these sets of p-values. But the result is visually very obvious from looking at this graph. The p-values were much, much higher for the replications than they were for the original studies. So that's a remarkable phenomenon. So one of my colleagues from NASA, a guy named Dov Edelstein, he talked about when a result is significant based on the principle of ocular trauma. By that, he meant the result is so visually obvious in your graph that it just hits you between the eyes. This is an example of a result that is significant by the principle of ocular trauma. So here's another way of looking at the results. So here, we again have the original studies and the replications. And then along the y-axis, we have the effect size of the experiment. The effect size has been normalized into a correlation coefficient. And so correlation coefficients always vary between -1 and 1. And the effect size is always expressed for the original experiments in the positive direction. So you see that the effect size for the original studies goes from 0 up to 1. In other words, even if the original experiment had a positive result that resulted in a negative number, so some treatment made somebody less anxious, say, that was flipped to be a positive number. And so here we have the quartiles and the median effect size for the original studies. And then here we have the effect size and of the replications. And again, the result is visually obvious. The effect size for the original studies is much higher than the effect size for the correlations. So now I'm going to show the results in one more graph. And this next graph kind of combines both of these graphs, and it's really quite a beautiful graph. There's a lot going on in this graph, so it's worth some time studying. So here, along the x-axis, we have the original effect size, again, from 0 to 1. And here on the y-axis, we have the replication effect size, going from -0.5 to 1. And here, this dashed line is an effect size of 0 for the replications. Up here, we have the effect size for the original experiments shown as a distribution plot. And so the blue here, this is the distribution of the effect sizes for the significant results. And then this small plot here, this subplot, is the distribution of the effect sizes for the insignificant results. Over here, we have the effect sizes for the replications. So the significant replications in blue and the insignificant replications in red. So you can see a large difference just between these two probability distributions. This line represents the original effect size matching the replication effect size. So in each specific experiment is a dot. So dots near the line had the same effect size for the original experiment and the replication. And then successful replications, that is replications where the p-value was also below 0.05. Those are shown in blue. So those are the successful replications. And then the ones in red here are the unsuccessful replications. So you'll notice that a number of the successful replications fall along this one-to-one line. And for a few experiments like this one, the size of the effect went up in the replication. But predominantly, the experiments that were not successfully replicated, they all fall below this line. So again, the results here are visually obvious. The replications had significantly smaller effect size, and that was correlated with an unsuccessful replication. Any thoughts and questions about this? The Discord shows. Okay. So now we're going to look at the results along several additional dimensions. So the initial strength of the evidence predicted the replication success. So if the initial p-value was very low, less than 0.001, 63% of those replicated. If the p-value was less than 0.02, 41% of those replicated. Between 0.02 and 0.04, 26% of those replicated. And then less than 0.04, 18% of those replicated. The next finding was controversial. The writing about this in the paper is very careful. But cognitive psychology was more successfully replicated than social psychology findings. So 50% of the cognitive psychology findings replicated, but only 25% of the social psychology. So cognitive psychology is more, came from more repeated measures designs. Those are designs that used methods that I think are more similar to what we use in our work. Social psychology, harder to measure, but I think you can see why this would have been controversial in the psychology field. So generally, there were weaker original effects in social psychology. And cognitive psychology used more within subject repeated measures types designs. So some additional results, and these are going to be results by percent replicated. Main effects were more successfully replicated than interaction effects. So in general, main effects have a higher power than interaction effects, and they were more successfully replicated. I think this next set of effects are some of the most important when we talk about the implications of this work and what it might mean for our own field. So here we're going to have the results by correlation with replications. So what was correlated with successful replication? So surprising effects, effects that were rated as surprising, were less reproducible. There was a negative correlation between a rating of an effect being less reproducible and the probability of that effect being replicated. So the more surprising the result, the less likely it could be reproduced. Now think about this. Journals and conferences like to publish results that are surprising, but they are less likely to be real effects. Challenging experiments were also less reproducible. So unsurprisingly, I guess, challenging experiments were more difficult to replicate. The importance, a rating of the importance of the original result had little effect, slight negative correlation, but it didn't really matter if the original result was rated as important or not. And the team experience and expertise had almost no effect, so a very small effect. So essentially, all of the teams appeared to have the experience and expertise necessary to conduct the experiments. So, and then the quality of the replication, that had almost no effect. So all of these correlations are negative. The positive correlations were the ones that we have already seen. Larger original effect sizes were more reproducible. Larger replication effect sizes were more reproducible. And replications that had more power were more reproducible. So the higher the power, the more reproducible. So to summarize the results of this experiment, even though the replications used materials from the original authors, were reviewed in advance by the original authors to be to have the right methodology and so forth, and had high statistical power. So these are all things that, you know, are good experimental design practice. Despite all that, the replications produced weaker evidence for the original findings. The strength of initial evidence, the p-value and the effect size, this is what predicted the success of the replication. The characteristics of the teams and the original finding, those had no impact on the success. And why were there so few replications? So that's the next thing to ponder. So this was suggested at the beginning of this tutorial. The reason were the biases. Publication bias, only significant results are published. Selection bias, only significant results are selected for analysis. And reporting bias, only significant results are reported in the paper. Because of these biases, the effect sizes of the original studies were inflated. For the replications, unlike the original studies, all of the results were reported, so there was no publication bias. And all of the confirmatory tests were based on pre-analysis plans. Therefore, there was no selection bias and no reporting bias. So everything that was planned was analyzed and reported, whether it succeeded or not. So the lack of biases are likely a big part of the reason why there were so few replications. Any thoughts about all this? Okay. So now we're going to kind of go a little higher level from the specific project and talk about some more philosophical questions. So we have an experiment and it finds an effect, which we'll call A. And then we have a replication. And the replication does not find A. How can it be? Like, what does this mean when the original study has a finding and the replication does not repeat the finding? What does that mean? So it might mean that the original study was wrong. And the true state of the universe is that A is not true. But another possibility is that the replication study is wrong. And the true state of the universe is that A is true. So this has a nice logical symmetry to it. But it's not, it doesn't cover all of the possibilities. The last possibility is that both the original study and the replication study are actually correct. And in this case, the true state of the universe is that A could either be true or false. In other words, the truth or falsity of A has not been established by either the original study or the replication. So you might be wondering, how could number 3 be the case? So number 3 can be the case because no two studies are identical. Many things can differ between an original experiment and a replication. The experimenters, the participants, the methods, the equipment, the analysis. There can also be random variation. So there could have been a type 1 error. There could have been a type 2 error. So think again about the first story, scientific story of this tutorial. So at first, Aristotle found that the rock fell faster than the feather. That study was correct, considering air resistance, which Aristotle did not know about. The replication was also correct when Galileo dropped the metal balls. The replication was correct considering air resistance. So both were correct results. If A is Aristotle's original theory, then A was false. Some reproducibility scholars, including Brian Nosek, believe that number 3 here is the most common reason for results not replicating. So this will be an interesting topic, I hope, for some future discussion. Why is it that things cannot replicate? So first impressions are often false, and it can be hard to detect the difference between a real result and noise. Another reason for irreproducibility is that if you run enough hypothesis tests, you can usually find something. Now, it is possible to address this in an experiment by adjusting something called the family-wise alpha level. But still, generally, if enough hypotheses are tested, usually one or more will end up being below 0.05. But the real reason for irreproducibility, the most fundamental reason, is that the incentive structure of science does not maximize the yield of true results. So we are incentivized to find significant, novel, and surprising results. If we find these results, then we get papers, we get funding, and we get degrees, we get career advancement. So these incentives result in many exploratory studies. This is the case in our community, and it is the case for every other field of science. The incentive structure of science pushes us towards exploratory studies. But if an exploratory study has a result that is spurious, evidence for that fact will not be determined until a replication is attempted. So that is likely the deepest reason for non-reproducible results. The incentive structure of science and the social constructs around the way the scientific process happens. So, some more thoughts. Suppose that a study finds A, and the replication study also finds A. What does this mean? So previously we looked at what it might mean when an experiment is not replicated. But what does it mean when an experiment is replicated? What does that mean? It means that A is a reliable finding. It can be replicated. But what about the theoretical explanation for A? So that could still be wrong. So once again, we have the example of this story. The original theoretical explanation by Aristotle was wrong, even though dropping a rock and dropping a feather can be easily replicated on the Earth, and as we saw, it could be replicated on the moon as well. So understanding the reasons for A often requires multiple investigations. It's one thing to find a phenomenon, it's another thing to adequately explain it. So multiple investigations provide converging support for the true explanation and help rule out alternative or false theories. So the question earlier was, what is the use of replications? A big use is not only replicating the result, but helping to uncover the true reason for the result. So another thought is, how many studies should be reproducible? So the reproducibility project reproduced 36%. Is this number too big? Is this number too small? Seems kind of small, right? But what would 100% reproducibility mean? What would it mean to reproduce every experiment? What would that mean? If everything was always repeatable, then that would suggest that we always know what's going to happen before running an experiment. And that would raise the question, if we know what the result's going to be, then why are we running the experiment in the first place? The knowledge is already there. Think about an experiment where somebody is dropping rocks to see if they fall. We wouldn't think that that experiment added very much to the state of knowledge, because we already know that that's going to happen. So the perfect percent reproducibility is probably depends on the field and the subfield and is likely unknowable. Maybe it should be higher than 36%. But basically, progress requires both exploratory studies that provide innovative ideas, new ideas, as well as confirmatory studies. These are replications. So innovation points out ideas that are possible, but replication points out ideas that are likely. And progress in the field requires some mixture of both of these. So the scientific incentives around funding, publications, awards, advancement, these should be tuned to encourage an optimal balance and a collective effort of discovery. So Florian's hand went up. You have a comment, Florian?
Yes, indeed. I was just wondering if you think that pre-registrations could solve both things, so you can have an exploratory study, and you then no matter what result you get, it's going to get published basically. And if it's kind of significant, then you know that it's worth kind of doing a replication on this. So of course, you can also try to replicate a negative result for reasons as you already talked about. But do you think that that might be a way forward?
Yes, but it might be. But a problem I've noticed with pre-registering what we could call an exploratory study is often when we start the experiment, we think we know everything about what the experiment's gonna, like how it's gonna run. And then the attempt to run the experiment, you know, when the experimental idea meets reality, we have to change so many things that in order to make the experiment happen, that it seems hard to pre-register at that level. So I think pre-registration is a good idea, but in the work of my own lab, I haven't yet figured out where it makes the most sense to do.
Mhm.
Now, when students are producing a thesis, the structure of that at my university has a bit of a pre-registration requirement, and that the student has to propose their thesis before they fully run their thesis. And so the rhetorical effect of that is sort of like a pre-registration, and that the experiment is described and the anticipated analysis is described before the student does the work. But it's not the same thing as publicly pre-registering it. You know, that's a university phenomenon.
Mhm.
And that is helpful. You know, students are kind of forced to really think about what they plan to do when they've done part of it, but not all of it.
Mhm.
Arifan himself is kind of in the middle of that process, so he might be able to comment on it from that perspective more. You know, where he thinks he knows what his dissertation will encompass, and you know, still unfolding.
All right, thank you.
Yes. So this brings us to the last part of this tutorial. What should we do about it? We being the ISMAR and VR community, the community of people developing virtual and augmented reality experiences, XR experiences. So the first take that I have from this, reading this paper and so forth, is that we as a field should value replication studies, and we operationalize that by accepting them. We should also value exploratory studies, which we already do. Basically, we should value studies that are well done, regardless of the type of study and regardless of the significance of the results, if the study is well done. And that requires changing our incentive system. So one change to our incentive system, which has been in this tutorial since I gave it for the first time in 2018. And I think this has had some effect already, is less emphasis on surprise. So we saw that surprise was negatively correlated with repeatability in the reproducibility project. And so here are some reviewer comments that I've gotten on papers that I was part of over the past 15 years. And all of these came from negative reviewers. So these are 3 different papers. Not all of these papers were rejected. Not all of these papers were accepted. And of course, I'm not trying to claim that my own papers should always be accepted. And my own papers have not always been accepted, so there's no danger of that claim. But notice, and all of these, though, are from reviews that were overall negative, arguing against accepting the paper. And so notice that all of them are talking about how the work isn't really valuable because the results are not surprising. So my own experience involves close to 30 years of doing empirical research of one sort or another. And then I've had some leadership roles in the VR and ISMAR communities over the past 8 years or so as a program chair and also as a general chair. And I've just seen what I think is too much emphasis on novelty and surprise in the review process. As people collectively running this conference, and everyone attending is part of running the conference, everyone who ever serves as a reviewer is also part of running the conference. So as people running this conference, we cannot directly control things like how our funding agencies work. We cannot control things like how the advancement systems work in our places of employment. We can't control these things, but we can control how our review system is conducted. That's what we can do. We can also educate the field, other reviewers, editors, about the replication issue and value replication studies. I want to emphasize that this year, the reviewer instructions had language about not rejecting papers just based on surprise. And so I think that kind of language is a positive development. And there was similar language for last year's VR conference as well. So recommendations, value replication studies. And if they are accepted, people will do them because then people get career advancement out of doing them. Another idea is pre-registering, which again is somewhat of a complicated idea, but what is a pre-registration plan? Before collecting the data, create a detailed written plan, the hypothesis, the methods, the analysis. As I mentioned, this is all commonly done in the cause of a thesis or dissertation at the proposal stage. So that's common in many programs where the student proposes what they do before they do it. This removes the possibility of the biases we mentioned. These biases are referred to collectively as p-hacking sometimes, where you're just looking for significant p-values. Even better is to publicly pre-register the plan. So in addition to a thesis proposal, can go to places like the Center for Open Science. So the Center for Open Science is a organization that Brian Nosek and some of his collaborators developed about 10 years ago. It started with some pretty significant funding from the Gates Foundation and other places with the hope of improving the quality and reliability of science in general. And there is a pre-registration challenge that's part of the Center for Open Science. And so, whoops, there it is. So here's an area where the experiment can be publicly pre-registered. Another idea, recommendation, is to run a larger study. So generally, in any experiment, more participants means more experimental power. But there is a risk, of course, because a larger experiment is more expensive. Another recommendation is to describe the methods behind an experiment in more detail. It's easier to repeat an experiment when more details about the experiment are developed. A problem in our field are the limited page budgets. It's very hard, I find it at least, very hard to fit one of my lab's experiments in 8 pages or 9 pages. And what are some of the solutions to the page limits? So one solution, which is possible in Tvcg, is to put additional details in supplementary material, or perhaps in an associated thesis or dissertation. We could also adopt longer page limits. This is something that I've been arguing for a few years, and we have gained a page over the past 5 years. Our limits generally used to be 8 or 9 pages, and now they're generally 9 or 10 pages. Another idea that is used in many journals, not our journal so far, is to have the main paper in a bigger font and the methods section in a smaller font. So this is a technique that is used in Nature. So let me show you an example of that. So this is a Nature paper that that I've referred to a lot in my own work. And we have our abstract, we have our experiment, our diagrams. This is all talking about the experiment and the results and what it means. And then at the end of the paper, after everything else, we have a method section. And here we have the details, more details about the experimental method. Notice that this is even in a smaller font. So this is a rhetorical structure for a research paper that is used in the journal Nature. And we could consider doing such things ourselves as well. Another idea is to upload materials to open repositories. So there is the Center for Open Science. We already looked at that. Within the IEEE professional organization that we are all part of in this community, and I didn't look up any of these for ACM, but I believe there are similar things that are part of the ACM organization as well. Maybe Florian can talk about that some, but very few of my own works have been published in ACM related venues. And so I'm much more familiar with the IEEE venues. So there is the Tvcg replicability stamp. And so here is that. And so in Tvcg, if your paper meets certain repeatability measures, you can get this stamp. And it's something that appears on your paper. I'm actually not sure exactly what it looks like, but I want to point out that under Tvcg, when they talk about replicability, they're focused more on algorithmic repeatability, because the majority of the papers in Tvcg are reporting some sort of algorithm. And so this is, can somebody else implement the algorithm and get the same results? It also refers to experimental repeatability as well. There is the IEEE data port. So the idea behind here, the data port, is that your paper can refer to the data that you analyzed. Of course, you would need to anonymize this data properly. If it comes from human subjects, you don't want their names or things like that up there. But properly anonymized data, where readers could take your raw data and reproduce your results. That's a very powerful idea. The IEEE data port promises to archive your data in perpetuity. So sometimes in my lab, we look up papers that are 100 years old or more. Some of the perceptual methods that we use were first reported in like the 1800s, and we've looked up those papers. That's the promise of a library that archives something in perpetuity. But when we look up an experiment from, say, 1880, we never find the data, the raw data that they collected. Wouldn't it be cool if we could? Now think about somebody 100 years from now, when all of us are gone. 100 years from now, not only can our paper be read, but our data sets can be accessed. Do you think anyone will access your data in 100 years? I mean, who knows? There's been several papers from the late 1800s that if the data set had been available, my students and I would have actually downloaded that data set and looked at their numbers again. I mean, what a marvelous thing. So the IEEE data port, a place where data can be stored. IEEE Code Ocean. So this again is more related to algorithmic repeatability. But the idea of the code ocean is that your source code would be archived, and this uses virtualization technology. So your source code would run in a replication of the operating system that was used. Now, in our field, HCI, I mean, how would we repeat the experience of wearing a particular headset or something? I don't know. That's a harder issue. But still, the point here is that the idea of repeatability has expanded across science and engineering, not only for human subject experiments. And then, of course, additional materials can be uploaded to archive, and I didn't mean to do that yet, to archive and other preprint servers and other repositories. And I'm sure there are similar repositories now that are part of ACM. So my last slide, or almost last, I think. Yes, it is my last slide. So what are the reasons for optimism? The current zeitgeist among journals, funders, scientists, the zeitgeist indicated by this very workshop is that people are paying more attention to the issue of replication, statistical power, p-hacking, these sorts of things. In psychology, journals have begun publishing pre-registered studies, and scientists from many labs have now collaboratively replicated earlier studies. There's the Center for Open Science that was established in 2013. And it developed some standards and is still developing standards for transparency and openness. What does it mean to pre-register? What sorts of information should be provided to pre-register? And this next part is over now, but they got a grant of $1 million, I think from the Gates Foundation, for part of a pre-registration challenge. So the first 1,000 teams to pre-register their results got $1,000. And so here are some references from the previous slides and some contact information for me. And all of the tutorials that I've given in my professional career, which I've been doing this for more than 20 years now, are on my academic website, and this set of slides will also be there soon. And
okay,
so, that's
thank
it.
you so much. I think we have one more question here.
Okay.
In the Q&A, maybe you can have a quick look.
No, no, I can see that.
Okay, let
Can you pull that?
me quit sharing my screen so I can see the Slack. Here, I'm going to stop the sharing. So I see, there we go. And
I
let me
also
get-
posted it in the Discord channel, whatever it's more convenient for you.
There it is.
Yes.
Now I can see Discord again. Okay. Okay, so do you think incentivizing researchers to share the data collected could help reproducing previous studies? Absolutely. So we have a story from our own lab, a recent story. Arifan and I and some other co-authors have submitted a paper for publication. And since it's under submission, I guess we can't really say what the paper is about, but we were able to get some data from the original authors by contacting them and saying, can we have your original data? And we were able to replicate their analysis and then extend it. Like we were able to subject the original data to a new type of analysis, and then the data we collected for the replication part on that same analysis and find some new information out of the original data. We were able to do that because we had access to that data, which we got not because it was publicly provided, but because we made an arrangement to get it. So I definitely think that that would help. There's this notion also from the data science community of publishing data sets. So let's see, I guess I'll type this, I'll type it here in the Discord channel. And so if you go to kaggle.com, let me make sure that yeah, kaggle.com. So there's like 50,000 data sets. This is a Google service. There's also the notion in data science of the scientific workbook. So instead of a paper being a static, published thing, it's in the form of a workbook where the data set is dynamically opened and the data graphics are drawn, and this is live as you're reading it. So in this case, the data could change and the results could change. So for example, many of the websites that show kind of the current status of the COVID pandemic are in the form of scientific workbooks. There's a mixture of, this is related to the notion of literate programming as proposed by Knuth long ago. And so I think the answer is yes.
Okay, so thank you so much. Everyone, as we are running a little late, exactly, I think we have it now 15 past, we're running 20 minutes late. I would suggest having still a short coffee break now. It would be officially in 10 minutes, but let's just do it now. Yeah, you're having your coffee all the time. That's very, very good. And let's maybe meet back at 4:30 or in 15 minutes. And Arifin, you will continue with your part then. Is that fine?
Yeah,
So
sounds good.
It would be 4:30 in Central European summertime or Bari time, and please translate that to your time zone or just be back in 15 minutes. Okay, You can leave your Zoom client open and we can meet each other in Town. Okay, thank you so much. See you in a few minutes. So Arifin, are you ready?
Oh, yeah, just a moment. Let me share my screen and
Yeah, no worries.
I'm from Dr. Swan's computer, just sharing.
Okay, we can see your presentation. All is good. So then maybe let's continue, and please go ahead, Arifin.
Okay. Thank you, Ian, and welcome back, everyone. I am Mohammad Safai Arifin. I'm a PhD candidate from Computer Science and Engineering Department of Mississippi State University. And in my presentation and in my talk, I'll talk about different replication typologies and the status in mixed reality. And I'll talk about the current scenario of replication in human-computer interaction, as well as in the field of augmented and virtual reality. So started with status and empirical research. So in the experimental, the study we have is the experimental studies. And we can divide that experimental studies in two categories, as Dr. Swan already discussed, the exploratory studies and confirmatory studies. The exploratory studies, which brings possible new ideas and innovation in a research field. And on the other hand, confirmatory studies confirms the previous finding or results by replicating the prior research. So from these confirmatory studies, we got the word replication. So the first question is, what is replication? I mean, just a common understanding. So Nosek and Arrington in 2020, they're stating that according to our common understanding, replication is repeating a previous study's procedure and observing whether the prior finding reoccurs or not. However, this definition is intuitive, easy to apply, and incomplete. For that reason, they came up with some more formal definition of replication. So they are mentioning that replication is a study for which any outcome, they focused on the word any outcome, would be considered diagnostic evidence about a claim from prior research. So when they're talking about the any outcome, they are basically talking about the successful outcome and unsuccessful outcome. So they mentioned that in successful outcome, which actually giving us the confidence on the prior findings or prior claim and about the research. But what about the unsuccessful outcome? They're saying that this is not fully useless. They are mentioning that unsuccessful replication indicates that reliability of the findings may be more constrained than recognized previously. So what actually they're trying to tell us that more exploration is needed about that research that we have unsuccessful replication. So from that unsuccessful replication, there is a term which is given by Rosenthal in 1979 came. It means the file drawer problem. So what is actually the file drawer problem is? File drawer problem is the bias toward publishing a successful research, only the significant research, what is already discussed by Dr. Ed Swan about the research or publication biasness. And unsuccessful replication could be stored away in someone's file drawer and never be published. So from this unsuccessful outcome, Rosenthal mentioned about the file drawer problem. So next thing is, what actually the goal should be a goal of a replication study. So a replication study could do any of the following things. It could verify the previous findings. It could validate a previous experiment. It generalized and established a research findings that are already observed by other researchers. So therefore, the goal is to verify, validate, and generalize, and as well as establish a prior theories, hypotheses, models, and findings in the research community. So then I start to explore, okay, what type of replication we can have. So what I actually found is that there is no general replication classification, and it highly depends on what type of research disciplines are you from. So I found a paper by replication types in experimental disciplines by Gomez, Natalia, and Sura. And what they found is there are total 18 replication classifications. I mean, there's quite a lot. Just the classification is 18 types. And from that 18 replication classification, they found in total 79 replication types. So this is quite a lot. And there are some overlap of different type of replications. And they found that most of them came from a social science research disciplines, some came from a business disciplines, and the rest of them from the philosophy disciplines. And they provide a classification chronology about the replication typologies. And they mentioned that the most cited or most preferred by the researchers one is the Likens one and the Hendrix one. So in the next two slides, I'll discuss about these two typologies, what the classification of the replication means. So Likens classification, he gave that in 1968, and he mentioned that replication studies can be divided into three types: literal replication, operational replication, and constructive replication. Literal replication means this is like an exact replication. Therefore, asking the same or original investigators to run the same experiment again, and whether the findings are consistent or not. This is the literal replication according to Likens. The second type of replication is the operational replication. Therefore, you have the experimental recipe, and now the original experimenter tell the secondary experimenter saying, hey, this is my experimental recipe. Now you do the experiment by yourself, and then compare the results, whether the findings are consistent or not. This is the operational replication. The other replication is constructive replication. So constructive replication is replicator formulate his own methods of sampling measurement to investigate the same research questions. Therefore, the original experiment and the replication experiment have the same research goal, same research questions, but they're exploring the same thing with different method or different approaches. Then I explored the Hendrix classification, and Hendrix also divided the replication studies in three types: strict replication, partial replication, and conceptual replication. And these three types is highly overlap with the Likens classification, what I already discussed. So the strict replication means replicating the original study as exactly as possible. So in this type of replication study, basically the experimental variables, experimental method, procedures, and most of them are exactly same as the original study, which is highly matches the literal replication. The second type of replication is partial replication. Therefore, replicating the original study by intentionally modifying a portion of the experiment to see whether those factors actually influence the original findings or not. The third replication type is the conceptual replication. That means using different method and different approaches to explore the same research questions and findings, whether the earlier findings are consistent or not, which is similar to the constructive replication provided by the Likens. So these are the two types of replications classification, and so that a replication study can be classified at any of these three types, whether it could be strict, partial, conceptual, according to Hendrix classification, or the according to the Likens classification. You already see that it can also be classified in three types. So any questions or any thoughts on that? Any question of it?
No.
So then I started explore at the very similar domain of augmented virtual reality, the human-computer interaction domain, and want to explore like the extent of the replication studies in that research domain. What I found is a paper by Casper, Soren, Xavier, and Jacob, and the paper published in Chi conference in 2014, and they're saying that is once enough on the extent and content of replications in human-computer interactions. So what actually they did a survey of the human-computer interaction papers from 2008 to 2010, considering a key conference on human-computer interaction and 3 highly ranked journals. That means this is their full sample. So after getting their full samples, they still provided some criteria. Then the paper should be empirical, it should have the quantitative data, the paper should report an experiment, and the paper should have a study where a human is interacting with any type of user interfaces. So based on that eligibility criteria from the full samples, they got the eligible papers. So here is the table they provided in their paper, and you can see that they found total 891 total sample size, and from them, they have 429 eligible papers. The next question is, then what count as a replication? So then they also set up some criteria for the replication studies. They're saying that a replication study should have an attempt to confirm, expand, or generalize an earlier study's findings. And then they found the 28 replication studies from their survey. So let's focus on this table. So in this table, the authors provided different replication types. They mentioned that there are in total 28 replication papers, which is 6.5% of the total eligible papers and 3.1% of the full sample size. Therefore, they started to have a full sample of about 900 papers. From there, they have 429 eligible papers. And from that 429 eligible papers, they have a 28 replication papers. So this is actually like pretty small set of the replication papers from a big set of the papers. Then they explored the question, are earlier findings confirmed? So from their exploration, they mentioned that among those replication papers, 14 papers performed a successful replication, and 3 papers failed to replicate, and 4 papers didn't define whether it is successful or unsuccessful. Then the thing is, whose work is replicated? They found that 22 studies replicate the work of other researchers. Therefore, other researchers perform a replication of the original work. I mean, the same authors are not there. Only 2 studies where the same author replicate their own work. Then they did a very interesting thing. So they contacted the authors of that 28 replication papers and gathered their thought behind their experiment. So 13 of the papers reported that yes, their paper contains the replication. But the interesting thing is that their main goals while conducting the experiment was not performing the replication study. Their goal was to extend or find new additional findings based on the prior research. And for achieving this, they are performing the replication. However, their initial goal was not to replicating the original study, but they're unintentionally performing the replication. So which is actually quite interesting. I mean, for me, like you were doing some research and you were not sure that you're doing the replication research or not. So I did the further investigation on human-computer interaction and found that different times, different people are talking about the replication crisis and replication studies in human-computer interaction domain in the Chi conferences in different times. I also found that in 2013, they actually arranged a workshop like we did here, like Replica 2013, workshop on replication of HCI research. So based on my knowledge, I found that this is the only time they are arranged that workshop. After that, I didn't see any workshop on replication in HCI. Maybe Florian can talk about this more. After exploring the replication studies in human computer interactions, then I focus back to my own domain. What is the condition of replication, and what is the extent of replication studies in augmented and virtual reality? And based on our knowledge, I didn't found a survey or review paper that has systematically investigated the replications in AR/VR research domain. Therefore, we do not know the extent of replication in AR and VR, and we do not know the content of those replications. So therefore, I have an effort for the replication survey, and our own replication survey. We started to investigate the replication studies in augmented and virtual reality. And this is the collaboration between the Mississippi State University and Coburg University in Germany. And our first step, we have a 3-step goal. And the first step is to select the full sample size, which is actually our considered papers. For example, here I'm just considering the IEEE ISMAR venue as our considered papers. And we considered a year range from 2010 to 2020, that means 11 years, and we considered only the peer-reviewed conference paper, not the journal papers, just the peer-reviewed conference paper. After that, we provided some criteria. We provided the criteria that this experiment should be related to the augmented virtual or mixed reality. The experiment should be empirical, and it should have a quantitative data. Therefore, we are focusing on human-based study. We are not considering a computational studies or algorithmic replications. We are just considering the empirical replication in this case. Therefore, after providing the criteria from the considered papers, we have the list or set of eligible papers, which basically are giving us the mixed reality user-based studies. And from this set, we get our replication papers. We also provided some criteria for our replication papers. I'm not mentioning here because this is just initial approach, but the main criteria is the replication paper should reference the original study, and it should have an attempt to confirm, expand, or generalize an earlier study's finding. Now let's look at some of the results, very initial results of our survey. So the first question is, were mixed reality studies replicated? The answer is yes, the mixed reality studies are replicated. And here I will show you the results of IEEE ISMAR for the last 11 years. So we considered the years from 2010 to 2020, and we found total papers to 304. And based on our eligible criteria, we found 113 eligible papers. And from that 113 eligible papers, we found 7 replication papers. And I have provided a graph of the total papers, eligible papers, and the replication papers. And you can see that 3 different colors shows 3 different type of papers. You can always see the green bar is showing the total papers, orange bar is showing the eligible papers, and the other color is showing the replication papers. And you can see the size of the replication papers is very small. One interesting thing we observed that replication percentage, what you get from the IEEE ISMAR is not, highly differ from the HCI samples, HCI percentage. That means in the previous slide, I showed you guys that human computer interaction have a replication percentage of like around 3%. And from the IEEE ISMAR in last 20 years is like a 2% of the total papers. In note, it's actually peer-reviewed conference papers. what we actually also observed that from 2011 to 2017, in this continuous 7 years, we didn't see a single replication papers. We have most of the replication papers from 2018. We have some in 2010 found, and 2018, 2019, and 2020, we found the rest or most of the replication papers. We didn't see the replication papers in continuously 7 years in IEEE ISMER. So then we divided these 7 replication papers in 3 different replication types. We considered the Hendrix replication classification, and from that we found that there's no strict replication is there. There's 3 of partial replications and 4 conceptual replications. We also observed that the 3 partial replications, which is actually conducted by the same authors. Therefore, same authors intentionally changing some of the experimental things and seeing whether the findings are consistent or not, according to the definition of partial replication. And all the conceptual replications were conducted by the different authors, which is actually pretty normal, like researchers from other fields. Other researchers came up with their own method and approaches to explore the same research questions. We also saw that among those 7 replication papers, 5 of them in augmented reality domain and 2 of them in virtual reality domain. So in future, we will continue this survey. We will extend our survey with more publication venues and years. Hopefully in future talk, I will show you the more results of our survey and the extent of the replication studies in mixed reality. And here are the references of my talk. And if you have any questions, feel free to ask me. Any questions or any thoughts?
Let's see.
Okay, so then thanks, Arifin, for giving that overview of, let's say, the state of replication in our own field. And I would say I will show our schedule one more time. Can you stop screen sharing for a moment?
Oh, yeah, sure.
It's over there.
Okay. And I will quickly share my screen again. So basically, Arifin took us through the replication typologies in the replication studies in WoRXxR. And let's put it like this, there's still room to improve regarding replication studies in our own field. And now we are coming to our session on the position papers. And the first position paper is by Daniel Hepperle and colleagues, and it's called Reducing the Human Factor on Virtual Reality Research to Increase Reproducibility and Replicability. Daniel, I would ask you to take over, share your screen, give your presentation, and then we open up the discussion. Okay?
All right. Can anyone see anything?
Yeah, very good. Works well.
Okay, so I guess I will have a quick start. Hello and welcome to this presentation. My name is Daniel Hepperle. I'm very pleased to talk with you about our work on the topic reducing the human factor in virtual reality research to increase reproducibility and replicability on this first of a kind workshop on replication in extended reality. The work has been created in collaboration with my 2 co-authors, Tobias Dienlin and Matthias Wölfel. I will give you a very brief introduction, but thanks to my previous 2 speakers, I think we are well prepared for everything I'm going to present now. And the very fact that we are all here sharing this workshop together shows that replication crisis has gained attention across disciplines. So what you can see here, on the left-hand side, you can see 3 of the disciplines where it's already widely acknowledged, like psychology, neuroscience, and communication. And since in human-computer interaction, or especially in virtual reality, we do share different, several methodologies, such as we do use questionnaires, theories, such as the technology acceptance model. And also there are the similar incentives, as Professor Swan already told us. Sometimes it's referred to publish or perish. So I guess we can assume that the problem originally causing the so-called replication crisis, such as a lack of robustness and trustworthiness, are very likely to exist in the field of human-computer interaction, or VR, as well. If we take a look at the situation in the field of VR, we can see that there are several works that already analyze that we do have a lack of statistical power, and as well as other coherent approaches to increase reproducibility and replicability, which does not come, to, at least to me, as a surprise, since many researchers from the field of computer science, in which, at least in my experience, are not very much synthesized in this direction yet. But on the other hand, looking at the procedures and methods used on a daily basis in computer science, many aspects arise that may qualify for higher reproducibility. For example, we do have those structures, approaches, we do have open source, to use open source to contribute to open source procedures, as well as the version control, which per se would help us to have an idea what happened in the program, and so on. While all these approaches are helpful, I guess, there's always one critical factor involved that cannot easily be coped by algorithms, and it's the human. But we don't want to talk about the human itself, because everyone makes errors, we make errors, that's no surprise. But if we have a look at what Decker in 2014 said, human error is not just about humans, it's about features of people's tools and tasks and working environment systematically influence human performance. So this is where we see this huge potential. For example, if you think of your first VR or AR experience, and how this setup has changed over the year, there are several things that we have learned. So recently, there has been several approaches in the field of virtual reality that try to support research produced by taking over redundant tasks necessary in almost every research project. One of those tools is developed in our lab. It's called Virtual Reality Scientific Toolkit. You can see it on the right-hand side of the slide. And in an earlier work of ours, we compared all those different toolkits that already exist on their features. I can hand you out the paper if you like to afterwards. And what all of them have in common, they try to simplify the research process by reducing redundant tasks. While these approaches are very helpful with our work that we present today, we want to take a look at how we can improve this research process in regard to reproducibility and replicability. To do so, let's take a look at a typical and, of course, abstracted research process that was developed by Koch. Here on the top-hand side, you can see several different aspects of a typical research process. It's from ideas to beliefs until point 7, interpretation and publication. And for each of those parts, they came up with several areas for concern that we already learned about it, for example, hierarchy or that lack of statistical power. And what we did in our work was to adapt all the features provided by toolkits, and in the following I will refer to ours, since that's obviously the one I know best. And we were talking about how to improve those areas for concern. For example, in the green section here, you can see those 8 points, and I will now introduce the first point. You always have to read it from top to bottom. So for process step number 4, experimental design, there's this concern, statistical power and confidence threshold. And here we provide the solutions on point 1. So we can increase statistical power by, we cannot increase effect sizes because they are given by the procedure itself, but we can increase the number of participants that take part in our studies by lowering the barrier to entry. And what I mean by lowering the barrier to entry is that when doing a virtual reality research setup, for example, if you want to measure emotions from avatars, we can just take the whole code base, share it on a server, and someone on another country can just download it and use it from for himself. And therefore, I guess gaining study participants would become easier because we do not have to bring them in our lab. Also, investigators can nowadays be shared easily, so I can be in my lab and someone else can be in another lab or in their living room, and I can take part as an investigator to guide through the setup. The next step, what we were talking about, is to provide established methodology. For example, we can present, in our toolkit, we can provide in-VR questionnaires to keep our presence, contrary to if we would ask the questions outside VR and the participants would have to put off their VR headset all the time. That would lower the presence, and that would be one established methodology that we implement in our toolkit. Also from the Korean Electronics and Telecommunication Research Institute, there's this motion sickness AI, which is not implemented in our toolkit so far, but could be implemented in order to reduce motion sickness, or to be warned before the experiment that it is prone to motion sickness. The next step is bringing different variables into context. And what we mean by this is, here you can see a prototype sketch. It's not implemented yet in this way, but we do have a replay function. So if we conduct an experiment, we can afterwards replay it and then bring all the different variables that we measure into one context. And the most important thing is they are time synchron. And we can have this feature in real time and via replay function afterwards. To increase generalizability, we do have predefined implementations that increase standardization and thus increase generalizability. For example, having predefined avatar styles, so that if one researcher takes his study and another one would do it, it would be of an advantage to have the same avatar styles. But it's only one idea that we can talk about. Yeah, it's I will relate to this in a further slide as well. The next step is lowering bias and increase external validity. And what we did also in an earlier work, we compared all those avatars that are provided by different social VR platforms. For example, Mozilla Hubs or Facebook Horizon. And as you can see, they do differ very much. And that's what I was talking about earlier. Also, there is research done in and on such platforms. For example, in WoRXxR, they do experiments. Yeah, so basically, by providing those predefined avatars that would not be so different, I guess we can lower these biases, and we can also, yeah, I guess that's it. Okay, and the next point that I'm really interested in, and that's a very, very interesting feature we are currently working on, is the normalization of the different variables within a multiplayer VR experience. So for example, if in a multiplayer environment, you have participant A, you have participant B, and if you want to measure, for example, the proximity, it would be influenced by both persons, but we want to measure their preferred proximity per participant. So if you take a look at this slide here, you can see what we did is for participant A, we did not alter they were just able to go next to the participant B, and we measured proximity. But for participant B in the same time, we measured the normalized proximity. He saw the participant A as it was before and could take his own proximity as he wanted to. So I'm already a little over time, so I will be very fast now.
No, don't be fast. We want to hear you. So
okay, okay, all right. Then I'm way more relaxed now. Okay, I already combined the 2 points 6 and 8 together, which are quite self-explanatory. For example, we do have standardized export protocols for better understanding. which comes with easier sharing of data sets and results. So if we have our predefined data structure, which we do have in our toolkit, we can use those structures in, for example, R, and just click on a button and get a typical eye tracking heat map. Also, this would obviously reduce time and effort for data export, which I guess is one of those barriers why people do not share that much of their research, because it's extra effort for which they are not paid for, or at least right now they are not paid for. We heard it earlier by Edward Swan as well. Okay, and one last point I would like to talk about is how we can increase Integrator reliability. And this also can be handled by the reply function. So every rater can have a second look after he took his ratings, and also we can augment what happened within the situation with all those different variables that we measure, and therefore can support the rating with all those automatic annotations. For example, we can have like what's it called, sentiment analysis after having put down the text, or we can have heat maps where the person was looking at, etc. Yeah. Okay. Then let's come to a conclusion and an outlook. As I've told you before, we argue that the field of human-computer interaction, or virtual reality, is particularly suitable for integrating those methods presented. Our toolkit right now is still in its infancy. What I really need to talk, what I would really like to talk about further is there is this difference. Are we doing research for virtual reality? So do we want to investigate how anything happens in virtual reality, or do we want to transport research from within virtual reality? How does this happen in the actual outside world? Yeah, raising awareness, I guess, is already done, or is on a good way by this workshop already. And I think further systemizing the scientific discourse makes the process and insights more transparent and thus more open. Okay, thank you all very much. I guess I can start with a short question, or if anyone has any question, feel free to ask. I was wondering, did any one of you already use one of those toolkits, or where do you see the largest potential so far?
Okay, Daniel, thank you so much for your presentation. So are there...
Daniel, can you maybe switch to the list of toolkits again?
Yeah, that would
sure.
it would help already.
I will start the presentation again. Can you see my screen?
Yeah.
Yes.
Okay, it's this one.
Yeah.
So actually, we have 8 different toolkits already, some of which are for Unreal, some of which are for Unity, some of which are for both toolkits. Only one is for both software game engines. Some of them are open source, more than half of them. But what was the question? I'm sorry.
No, I think there was no question by Florian. He just wanted to see the toolkits again, but you asked your question, and my answer is I never used any of those.
Same here.
Okay, so basically you implement your structure of code again and again, or you do have your predefined algorithms and use them over and over again, or how do you do it on your own over and over again? For example, like eye tracking is essential to almost every VR research project, I guess, in my opinion.
Yeah, please, Florian, please go ahead.
I will just stop sharing the screen so that I can see you again. Okay. Yeah.
So as I said, I'm not so much in the AR community, but what I've done so far in terms of AR was mostly centered around A-frame, and there's lots of plugins for A-frame that help you do many of the things you have there. But so far it's all been very, very small one-off prototypes where such a big framework kind of didn't really fit in, but it's not my main area. So that's maybe a question for Jens more than for me.
Yeah, and for the others, so maybe you can join the conversation on Discord and just see whether you have used any of those toolkits before or not. So I can comment on that we also didn't use those toolkits, and reflecting on the, let's say, quite a number of experiments that we do here in my lab. Apparently, yeah, we basically have our own processing pipelines, right? So best practices, and we use custom data transformation, data analysis pipelines, and we might hand them over from project to project or start from scratch. We probably would benefit a lot from, let's say, standardized toolkits, but why didn't we use them? I mean, maybe just also because sometimes you feel, at least at the beginning of a project, that what I assume what my students think of, that you feel more confident in starting that research and that analysis from scratch than reading yet another toolkit documentation and starting to deal with these issues of those toolkits, and then eventually coming to the conclusion that the specific feature that you are looking for is not even available. I mean, there's a reason why there are 8 toolkits. I guess there's a reason why, Daniel, you started yet another toolkit, right?
Yeah.
Why don't you use those other toolkits?
It's basically one of the headlines.
Yeah, because you cannot do the things that you want to do, right? And of course, this is a resource question, and I'm not sure whether there's an easy way out of it. Yeah,
I actually can agree on the effort on the first-hand side. Also, what one of our goals was when developing this virtual reality scientific toolkit was to enable researcher outside of field of computer interaction, of computer science, to be able to use such a toolkit with really easy user interface and stuff, so that they also can take part in virtual reality research without having to have a programmer around all the time. But we're not that far already, so
yeah. But by the way, I have a question: whether your research or whether your toolkit is actually already published. Just having a quick Google search doesn't reveal anything on that.
We presented it on the conference, on the Cyber Worlds conference last week. I'm not sure if they already published it. It's already published or not, but the conference was last week. But I can send it to you if you like.
Yeah, that would be
afterwards.
Much appreciated.
Okay, sure.
And just I have one more, let's say, comment to the community here. I also posted it in the chat, because you're of course raised an important issue of let's say getting enough participants for running a study in the first place, which many of us already struggle with in normal times, and during COVID it's actually getting harder and harder.
Yeah.
On Thursday there is a Thursday panel which is called Planning a Virtual Experience Research Accelerator, or short VERA. And I think it will be on Thursday at 4 p.m. or 4:30 p.m. 4:15 p.m. CEST, and at least established figures in our field, they are trying to propose exactly means to run studies remotely in, let's say, these research centers. So maybe you want to join that panel discussion as well if you're interested. Okay, I'm just looking at the chat and at the Discord channel if there are more questions for Daniel. If this is not the case, and thank you so much again. And
thank you.
Then Sven, it's up to you to take over.
Yes, thank you. I will share my screen. So you can see my screen, yes?
Yes, we do.
Yeah, okay. Then welcome to my presentation entitled Reflections on the Comparative AR Study. And I'm giving this presentation on behalf of my colleagues and co-authors Florian Jasche and Thomas Ludwig. So in recent years, AR technologies have been increasingly used for supporting remote scenarios and the presentation of complex instructions. And a variety of different hardware was and is used. And the possibilities of representation, placement of the holograms, and the interaction in particular are sometimes immensely different. And the far-reaching integration of technology into production environments, for example, and its use by people in practice repeatedly raises the question of how performance can be improved by supporting processes with AR. Therefore, many scientific studies focus on some measurement of performance with and without AR support, for example, Blatt-Gerste. And recent research also compares different AR visualizations and their impact on performance, like our own study. Overall, inconsistent results begot a lack of reproducibility in numerous studies. And actually, we can only speculate about the exact reasons, but too wide of a range exists consisting of study design, task to be performed, AR application, practice context, and most importantly, hardware use and underlying interaction form. When we come to related work, for example, Funk realized early on that both the task and the evaluation of similar ones needs to be standardized. And they therefore developed a standardized study design called a General Assembly Task Model. And with a Lego Duplo task and a task with more reference to the industrial context. The main argument to abstract a real assembly task to a Lego Duplo task is that the Lego Duplo bricks are affordable and easy to access. And this makes the task easy to replicate and scalable. It also represents the activities of real-world manual assembly tasks, for example, picking, placing, and assembly, but with a different complexity that cannot be compared with actual practice situations. Studies from Funk, Blatt-Gerste, and Smith follow the proposed general assembly task model and the Lego Duplo task study design, and is often easier to replicate because of lucid description and available paper instructions. However, even if the different AR applications are described, the source code is often unavailable, which increases the effort to replicate the study. Sometimes potentially influential information, such as the participant's age or experience with AR, are missing. Other studies like Khatkowski or Pringle or our own study, we are investigating the performance of AR in a real-world assembly and maintenance task. Khatkowski, for example, asked the participants to assemble an actual piston motor, which is not further described, and the actual instructions are missing. And detailed assembly instructions are also often missing in similar studies, which reduces reproducibility. And when we come to our own study, we evaluated two self-developed Microsoft HoloLens applications that provide hardware-centered activities, and we use different visualizations. And the main concept of both applications is to guide users in conducting complex procedural machine setup tasks through augmented reality instructions and with emphasis on novice users. When we compare concrete types of visualizations, you can see it on the figure right, it is clear that a concrete visualization is much more detailed and closer to the actual application. While in the abstract visualization, arrows or generic forms indicate points of action, the concrete visualization maps exactly the 3D models with the real work pieces. And they are giving the user a much richer description of the parts to be used and their location. In total, we compared 5 different visualizations. I explain it later on. This is a short video. You can see the applications, the different applications in a split screen, and they're used in the study. And the participants were, task was to equip a bending machine, you can see in the background, with a tool set. And for this purpose, various tools had to be mounted on the machine. And in the study, we collected a database on the performance of an identical complex task with 48 voluntary participants in total, and we recorded task completion time, error rate, mental effort as dependent variables. And all values were analyzed with a one-way ANOVA, and we instructed the participants to equip a bending machine, as you can see on the video, with a set of bending tools and using the predefined visualizations. We defined 5 different visualizations as independent variables: the abstract augmented reality with and without additional videos, concrete augmented reality with and without additional videos, and paper-based instructions. And during the design of our study, we primarily focused on the internal validity. So we conducted our study in a laboratory environment with controlled factors. We tried to create a homogeneous group for the between subject design regarding the prior experience with AR, as well as setting up machines. And we followed the same procedure for every participant. And we included all important data regarding the study procedure, for example, information about the participants, the machine name, the used questionnaires, to create full transparency in our publication and to ensure basic reproducibility. But we must admit that the reproducibility of our study remained theoretical because the tools of the machine to be mounted are unique, and to the use case we select is unique or something special too. When we come to some of our results of our study, this is the first key result is the task completion time, and the task completion time does not differ on average between the individual visualizations, so no significant difference were found here. The second key finding is the mean errors, though we can see that here are significant differences between the individual visualizations. And we see on the left that the abstract visualization differ significantly from the abstract visualization with additional videos, or concrete visualization with videos and paper-based instructions. When we come to the discussion of our results, we compared it with a study by Radkowski, because our study and the study by Radkowski are similar concerning the research question and the general study design, but they differ enormously with regard to the used hardware and the results. For example, Radkowski demonstrates longer completion times for abstract augmented reality visualizations, while our does not show any significant differences regarding the completion time. With regard to the error rate, the results are comparable in that both show that concrete AR visualizations lead to a lower number of errors. Radkowski concluded that concrete AR visualizations are more suitable for easy assembly tasks. This assessment is not plausible based on our study. If we compare the settings of both studies, we notice that there are 2 different assembly tasks, and Radkowski worked with a tabletop AR application and a display as the output medium. We use the Microsoft HoloLens. When we come to the discussion of these studies and our study, we realized that the studies by Funk, Blood, Gerst, and Smith, for example, use the standardized Lego Duplo task, but the visualizations are based on different hardware devices and therefore produce a colorful bouquet of results. As expected, the task and the hardware have a significant influence on the results of the studies, and there are also statistical influences due to the different group sizes and test subjects, for example. Finally, the test persons themselves and their prior knowledge, professional background, and affinity for technology are also influencing factors, as you heard before. So far, no consistent results are available on that basis, and no generally valid implications for the design of AR instructions can be given. In addition, the technology is still in an early phase of its life cycle, where there are constantly new developments in the area of hardware and software, for example. recently acquired knowledge from extensive studies can quickly become obsolete. Thus, the replicability of the results should not be in the foreground of the efforts of new studies from our point of view. Rather, the aim must be to identify the use case dependent design ideas. The use of standardized tasks such as the Lego Duplo task is not beneficial for exploring these possibilities from our perspective. On the contrary, these tasks do not allow AR technology to show its full potential. One of the main characteristics of augmented reality is that its context dependency, and user tests in a controlled environment remove a lot of the important aspects which might be present while using an AR application in actual practice settings. These controlled tests are conducted to increase the internal validity as well as the reproducibility. And from our point of view, there are several questions. For example, is high reproducibility a necessity while the AR medium is rapidly evolving? What does a publication need to make its AR study reproducible? Do detailed descriptions on the process of an AR-based study serve their purpose, or do we need to provide more information and material such as the used AR application in our case? And how can the strong context dependency of an AR application to the physical environment can be reproduced? Detailed information about studies procedure to increase reproducibility is often not possible due to the publication format with page limits and might also be viewed as unimportant compared to the results. So this is the point we heard before. And to summarize this presentation, our argument is not that AR studies should not be reproducible, but rather to take the full potential of the technology and explore new use cases and discover new design applications, even if the reproducibility is decreased. The sharing of one's own experience should be in the focus so that others might learn from it to jointly push the development of AR technology. And the second argument is that also AR technology is still relatively new. Its potential no longer needs to be justified by showing the advantages or even disadvantages of the technology based on performance measurements. So it's now a matter of demonstrating concrete areas of application in different contexts. In addition, long-term studies should now be pursued to explore the appropriation of technology and how expertise with AR and organizational settings evolve. One aim could be supporting the appropriation of knowledge-intensive operating processes through augmented reality. And building on the already demonstrated possibilities of AR in this area and the initial findings of appropriation support, long-term studies in real production environments are currently scarce. So, however, these studies are crucial for the further development of AR technology outside of the laboratory, and which will pave the way for a wide adoption of useful AR applications. So these are our two arguments for further development in this research area. So this is my presentation, and feel free to ask questions.
So Sven, thank you so much for your presentation. I mean, you brought up some interesting thoughts, but I'm just looking now into the round of the discussion participants in the chat or in the Discord channel. So please feel free to ask some questions to Sven. I mean, you made up some interesting claims which can be at least considered a bit contrary to what we try to preach here. So I think there should be some discussion going on. Just quickly looking there. Yeah, so Ed is writing something. So let me. Ed, you could also use some. Yeah. Okay. So Ed tells he likes ideas of Legos that they can be widely replicated. Yeah, which is good. But I mean, what Sven actually told us that even though you have these Lego bricks, it only helps to a certain extent, right? Yeah. Sven, I think a point that you made, and I think this is valuable to consider, at least for I would agree for application and interaction purposes. Your argument was, as I understood it, the hardware is evolving so rapidly, and let's say influencing the results so largely, so so big that it's actually of little use to try to replicate studies. Right?
Yeah,
Is
but
this-
I mean, you could replicate the same building task in Legos.
and I think this is what I think this as Sven. I'm not sure. I think this is what you presented, right? I mean, this was tried before.
This is one argument we made and we experienced because we made our study with the HoloLens 1, and I'm sure that our study would look completely different if you use the HoloLens 2. So what is the outcome of our study, and how long does this, or are the results of our study valid due to the fast evolving hardware and software tools? For example, the mixed reality toolkit by Microsoft, the first one and the last one differ so much. So I think that these influences are very, very strong, and it's hard to replicate the studies with evolving hardware and software, especially in augmented reality, also in virtual reality.
That's a huge challenge. How would you replicate the user experience of a certain era device?
Yeah, it's
the gaming industry helps. So we could probably replicate an experiment originally conducted on a common gaming factor platform from 10 or 20 years ago. You know, like a Wii or something. But how could we replicate from an old display? You know, it's hard to see.
And the question also becomes: do we need to replicate from an old display, right? Or are the likely outcomes are so different that it's that on new hardware that there is no real need for actually doing the replication in the first place? And I mean, this is a rather interesting question, right? Is it necessary to replicate using, let's say, old hardware? If so, how can we do it? Of course, and maybe we can not answer that question, but we can address it depending on the actually underpinned research questions, right? I think if it's about, for example, perceptual cognitive issues, and which let's say which relate to more atomic tasks or to more fundamental cognitive and perceptual psychology issues regarding our human information processing, then maybe it's worth to replicate things. When it's more about how do you support a certain task, a certain application task as best as possible, maybe there's actually no need to do that, but the answer would be you can likely do it much better today, and so let's just use today's hardware and software that is available and the latest interaction techniques to support the task at hand as good as possible. I mean, maybe this is also an argument here. But anyways, yeah, please, sorry.
Yeah, what we know is you can't do a, what did you call it, an exact replication, a literal replication without the original hardware. You can do a conceptual replication with new hardware.
But I think the question is, do we actually need a literal replication? Because it's not very much more generalizable, right? After we do a literal replication, in my opinion, it makes more sense to do a conceptual replication anyway, because then we have verified that the same concept can be applied in a maybe slightly different context as well, right? So that would and getting hold of like old hardware or even getting to run old hardware is really like a challenge on its own, I've found. So personally, I would rather try to aim for the conceptual replication anyway.
Yes. I guess the argument is if the phenomenon that the experiment has uncovered is strong enough, it should show up independent of the type of hardware.
Exactly.
Okay, I'm just looking one more time at the chat here. There are no further questions. We can and should probably continue that discussion, but we were running a little late. That's why, Sven, thank you so much again for sharing your thoughts here. And I would now come to the officially last presentation by Florian about replication and HCI and bioinformatics. What can we learn? So Florian, if you want to take over, the stage is yours.
Yes, let's see. Share. I hope this is working. You can see the slides, I'm hoping. Hello, slides, anyone?
Yeah, we can see it.
Yes,
okay.
Yes.
Excellent. So yeah, then I hope not everybody has already Zoom fatigue for this last talk. Yeah, I'm Florian. I already introduced myself, and this is work I've done together with Chet and Lukas from University of Zurich and Steve from Université Paris. And this was originally a Kai 2020 paper, and I've updated it a little and want to just give you a kind of an overview over what the current state of research artifacts is in Kai. This isn't actually going so far as what Mohammed talked about, which replication studies are in Kai. We only tried to look at are the preconditions actually met for being able to do replication at all. So do Kai papers even have enough information available that you can even think about replication? And so we already covered the motives and the incentives and so on for replication quite a bit. So I will skip over the next part a little quicker. So of course, the reason why we do this sort of research in the first place, or at least the fundamental reason, is that we want to improve on the human use of computing in the widest sense possible. And that is kind of a continuing cycle between research problems, hopefully finding solutions, and then finding improvements that then usually lead to new research problems. And that part, of course, only works if we have some prior work to build on. Google Scholar calls it standing on the shoulders of giants. And that's, I think, attributed to a quote attributed to Newton, if I remember correctly. And that's the whole point of research, right? That we have something to build on, as shown in this nice illustration, so that we can see farther than those before us. But of course, this is all like the philosophical underpinnings. I won't go into too much detail here. We already talked about this quite a lot. To actually be able to build on this information has arguably also helped with the rapid development of vaccines against COVID and so on. So everybody who's here, I think I don't need to convince you that this has value. But there's kind of a catch, and this is, if you look at HCI specifically, then it's a very broad mix of different disciplines that all kind of play into this whole thing a little bit. So ISMAR is maybe more on in this area with computer science and ergonomics and engineering. Kai, on the other hand, is maybe more in the psychology, cognitive science, ethnography area, and then there's all sorts of other specialized conferences and journals that cater to some other subset of this. But everything can be put together in the context of HCI, and that's might also be part of the issue here, because it's a lot more difficult to take the arguments that, say, Brian Nosek came up with for psychology and actually apply them to HCI, because there's some people who might consider themselves psychologists here, but there's also a lot of people who don't really have a lot to do with psychology in the HCI context. And to convince all of them is maybe sort of an uphill battle. So my personal kind of entry into the whole area, into the whole concept of replication and so on, came with this kind of little survey that I did together with a longtime colleague and friend, Max Häusler from UCSC. And he's actually a bioinformatician. So data processing, genome searches, that sort of thing. And since I also have a bit of a background in open source, and he has as well, we decided to kind of have a look at our respective fields and compare them. And so we did a bit of an analysis for Kai 2016, 2017, and compared that with the International Symposium for Molecular Biology, also in 2016 and 2017. And we had a look at, first of all, how many papers actually talk about open source. So this like preliminary analysis, my apologies, was mostly focused on the open source and software artifact aspect of things. So we had a look at all the publications, which one actually talked about open source, which ones of those released any sort of supplemental material. The ACM digital library also has provisions for that you can attach zip files or whatever to your publications. In which of those papers actually released some sort of source code. So there was, out of over 1,000 papers each year, there were 124 that talked about open source. And there were something like 25 roughly that actually released any sort of source code. So that's 2.0, 2.6% over those 2 years. And if we now compare this with ISMB, which is of course a different venue and a different subfield, but still it's also at least partly computer science, then we have a ratio of 36 and even 87% in 2017. So this is already like probably approaching 100% by now, because in this field reviewers simply ask for it. So and occasionally I've invited my colleague Maximilian Häusler also to be a reviewer on Kai papers that deal with bioinformatics, for example, and he also asks for source code. And he's probably one of the few that do that along with me, maybe. And unless that changes, I guess this number will not have gone up significantly by then. But when I presented this paper at Kai 2018, then I got into a talk with Chad and Steve, and they mentioned that it's a bit narrow to just look at source code alone. There's other types of artifacts, especially because HCI is so broad. And so we set out to try and define what can an HCI research project generate. So for example, we can have the study materials that can be something as simple as a questionnaire, but it could also be something as complex as a whole virtual reality environment that is part of the study and that's there to kind of trigger responses from the participants that you measure. Then, of course, you have data, either some sort of raw data, whether it's written text from interviews or whether it's measured data from some VR environment, for example. We have the processing procedures in itself. Again, this can be something manual, like classification of responses, some kind of coding manual, or it can be source code in, let's say, in R that does the statistics. And then we have the output itself, which is maybe statistical results or graphs or something like that. And last but not least, we have the prototypes, which can be software or hardware or both. Of course, this is sometimes a little hard to differentiate from the study materials, especially when you talk about things like VR or XR environments, but we chose to put up two different categories for this in our questionnaire, which I will come to in a moment. So first of all, before we actually set out to kind of do the survey, we already encountered quite a number of, let's say, misconceptions about the whole sharing data and opening up research concept. And for example, if somebody wants to actually use my my data or my code, then they have to just ask me. So I won't make it open, but if anybody asks, then I will hand it out. Yeah, nice sentiment, but in the reality, let's just wait a second. So other thing, which is actually a step further already, is to put that stuff on GitHub and kind of be done with it then. I've also been guilty of doing that. So it's very quick and easy to put up a GitHub project, and then it's at least shared, right? Or what's also actually a very hot topic I've encountered, especially in the Kai community, is that the data from the study participants should in no way be shared online because it's confidential. Also, there's a grain of truth in that, but do we really need to be so strict? So all of these things we already encountered before we even get to the survey. And other people have already looked at these questions actually. So let's see if it really works to ask people for the code of their data. And they were 141 articles in psychology journals that they evaluated, and they tried to ask for the data. And so in total, they got 27% of data actually sent to. So 11% actually shared the data immediately, 16% forgot about it and then shared it afterwards. So we have 27, but then 35% just refused or didn't have the data anymore. 4% had undeliverable email because of course somebody changed universities. No reply at all from 14%, and no data despite promised 20%. So maybe that doesn't work quite as well. And in biology, not just in psychology, in biology as well, they did a even longer term analysis of 516 articles up to 20 years of age. And so the regression here is not very well fitting, but let's say that on average you have a 17% decrease every year that the data will still exist. And after 20 years, it's probably more somewhere, or even, what is this, 22 years, somewhere around 25% that you will still be able to get the data. So that's actually kind of the same result as from the other study. So I think that kind of also underlines that just having people ask when they for the data is not something that will work long term. Same thing for GitHub, which is especially in software-oriented communities, of course, a useful way, but there's lots of things you can do to GitHub repositories to kind of make them vanish or make them be something completely different than they originally were. So you can delete it, you can replace it by another repository with the same name but completely different content. You can just remove everything. Then there was the acquisition of GitHub by Microsoft 2 years ago or so, and so far it's not changed a lot as far as I can tell, but who's to say? So Microsoft could still like turn off the free tie of GitHub if they ever want to. So for that reason, maybe also not such a good idea. On the other hand, OSF, we already talked about that, or Zenodo have a lot of funding. OSF for 50 plus years, Zenodo for at least 20 years. So there's a bit of longer term security here at play than on GitHub, which is actually also something to keep in mind, I think. Then the data about the study participants, of course, if you have like really sensitive medical data, let's say, then that might be something to consider. But if you actually need to collect information that makes the participants identifiable, so do you really need to know the exact age, or is an age bracket enough, for example? Can you anonymize it? Can you maybe put it in a protected repository that is only available after a registration, something like that? And of course, the participants themselves might actually not be that reluctant to share their data if they know about the potential benefits, for example. So if, especially in medical research, people can kind of choose to actually donate their data so that it can become public. And of course, usually under the premise that there is no identifiable information in there. But now let's come to the core topic, which is how well is this actually working in HCI, and of course, especially in Chi. So we kind of redid the original analysis, but we kind of chose to focus on a much broader set of research materials, and we asked the authors themselves. The original preliminary study by Max Häusler and myself, we only looked at source code, and we did it ourselves with use of some text analysis scripts. Now we asked the authors themselves to describe what they think they share. And so what we assume is that this can actually be considered an upper bound, because in many cases, so we did a few samples where we tried to verify the answers by the authors, and we found that the authors consider many things to be like sharing of data, for example, when all they share are actually the graphs generated by the result by the data analysis, for example. So that's kind of people usually assume they are more open or they share more than they actually do. But the questions we actually ask is, what types of these research artifacts does your research generate? And if you share it, then how is it shared? And if you're not sharing it, why are you not sharing it? We got 34% of response rate. That was actually more than we had hoped for. So that's quite a lot. And therefore, this analysis can also be expected to have a bit of statistical power. But the results are actually not that encouraging. So it's a little better than the original numbers I showed. But again, let me repeat, this is probably an upper bound. So for raw data, we only get about 20% of data being shared across both years. For the procedures like the data analysis, it's maybe a little higher, on average around 30. For the output data, it differs a bit between qualitative and quantitative data, but none of it actually goes above 50%. What comes closest are actually the software and hardware artifacts. So here we're slowly creeping towards the 50% mark, but still it's not that much. And the study materials themselves also around 30%. So there's still a big gap between what you would need to actually do replication on these results and what is actually available. So regarding the people who say if anyone wants to use my data or my code, then they have to ask me. There's actually quite a difference between the different types of materials. Basically, if people said they only share these materials on request, then that is very high for the raw data, and especially for for pre-selected raw data, people would be a little more willing to share that on request. For the completely unfiltered raw data, it's only 50%. So again, a lot of people kind of subscribe to that philosophy, so to say. But it's quite different across the different types of materials when they think they would actually share the data when somebody asks them. Stuff that's only shared on GitHub, as expected, that's especially true for the software and hardware artifacts, sometimes also for the raw data. The qualitative, both data processing procedure and qualitative output is basically never shared on GitHub. And that's an interesting finding, because I think that reflects back to what this diagram I showed before about the HCI community shows, that there's lots of different kinds of people in there. And the sort of researchers that do more the qualitative sort of research are obviously not the sort of researchers who use GitHub. So there's kind of a gap in here. Again, GitHub is maybe not the ideal sharing platform anyway, but it's better than nothing. Still, for people who do mostly qualitative research, it's apparently not the medium of choice. direction. And then here we had the concerns that people had about sharing data from participants online. So, so in most cases, it was that there might be sensitive data of participants, followed by not obtaining the permission of the participants explicitly to share the data. And last but not least, number three, don't see the benefit of sharing. This is, of course, an educational thing, basically. So I don't need to explain that to the people here in this workshop, I assume. But obviously, there's a significant number of people in the overall HCI community who still don't see the point of actually sharing the data. And maybe people do see the point, but still are too worried about kind of releasing data they should not release, at least not in their own interpretation. Sorry, I think I'm missing a slide. The idea is, of course, that you can anonymize a lot of data. Yes, there are tons of studies that de-anonymize data, but as I said, maybe the exact age of your participants isn't actually that important, and an age bracket is more than enough. And the exact postcode where they live is probably also not that important, and so on. So you can easily desensitize your data so much that, especially for some kind of, let's say, unimportant data, such as task performance in an HCI study, nobody will kind of change your insurance premium if they find out that you had a bad performance in a VR study, as opposed to maybe health data. All right, so again, preaching to the choir here, but you all know that it will actually be beneficial under the right conditions if you share your data. So the well-known €1 filter has a ton of implementations and source code. And for that reason, the paper itself also has quite a number of citations, which is the currency most people still deal in, as I said, or as others before me have already said. We also have a checklist. The details are in the paper of how to best prepare your paper for being able to actually share the data so that later reproduction will be possible. Also, instead of just dumping things on GitHub, try to use one of these fair repositories such as OSF. And also, think about these privacy trade-offs, while at the same time not to collect all the data you can get your hands on, because you might be able to use it later. That's also something that the pre-registration might actually kind of help with. In general, I think we believe, so we're convinced that if we consider research as a sort of craft or profession, then actually sharing these artifacts is part of this craft, and should also allow others to learn from kind of what we did, and maybe also what mistakes we made, not just publish the polished and glossy stuff that worked and file the rest in the drawer, as we already discussed already. I think one final comment that might be something to consider is that especially HCI in general has an interesting position here because it's very diverse. There is some expertise here in kind of analyzing work practices and also research work practices, for example. And there's some experience in building tools that can help people to make better maybe make better studies, share better data, collect better data, and so on. So this is, of course, hypothetical. Not a lot of people I know so far are working on that, but still there is some potential here in our opinion. And so I'd like to wrap up now, because I think we actually only have 10 more minutes for discussion. So here's some takeaway messages that I already described during the presentation briefly, link here as well. And Oh yeah, that reminds me, I would maybe actually suggest to collect the presentations in some sort of Google Drive folder afterwards. Jens is nodding, so maybe we'll have a chat about that afterwards, but so you don't need to collect a bunch of screenshots.
Or maybe not Google Drive.
Yeah, good point. All right then, so yeah, thank you for listening, and that concludes my presentation. And I'm hoping there are questions.
Okay, thank you so much, Florian.
So
Yeah, I have a question or a point, and maybe
Yes.
this is what you meant by the FAIR acronym.
mhm.
I want to point out about accessibility versus accessibility and perpetuity. So the nice thing about publishing a paper and having it in a digital library is the idea that after you pass on, it'll still be there.
Yeah.
Now,
Of course.
we have no promise that GitHub will still be in existence in 10 years. It seems inconceivable right now, but we have no promise. It's a business. Same with YouTube. All those videos, are they really going to be there in 10 years and 100 years?
Mhm.
You know? And I want to point out that 15 years ago, 10 years ago, there was a very popular site for open source software called SourceForge.
Yeah.
And I don't know if SourceForge, I mean, it doesn't, if it still exists, it seems to be on the down slope. at this
Yes, it's still around technically, but
Right.
it's kind of completely eclipsed by GitHub, I guess.
It is, but GitHub may be completely eclipsed by something else.
Yeah.
And so, you know, the current places like that, big companies, I mean, they may not be big in another decade or two.
Yeah.
And
Absolutely.
YouTube, I mean, Yahoo is an example. Yahoo has kind of infamously taken over various other sites that had a lot of user discussion and stuff and kind of early history of the internet, and then killed it, you know, removed it from the internet. So it's sort of like, you know, I've heard it described as an internet lobotomy, you know, what YouTube, what Yahoo has done. So to me, the very important aspect of the places that I mentioned that are part of the IEEE, you know, research community is the promise of perpetuity. The goal of those projects, Digital Library, Code Ocean, Dataport, you know, even if they're not as convenient to find or something as GitHub, there's the promise of perpetuity.
Mm-hmm.
That the next generation and the generation after that of people behind that organization are supposed to continue to have those materials available. And,
Absolutely correct. I mean, so
in terms of FAIR, the accessibility part of that acronym may be the idea of perpetuity, of long-term access. You know, that's a point I would like to make.
Mm-hmm. Exactly. And so that applies absolutely not to GitHub, but rather to OSF or the ones you mentioned. I mean, IEEE probably also has enough kind of funding specifically set aside for this repository to remain accessible for a long period. And
did you say archive? Or what did you just say?
No, the one from IEEE you mentioned.
Oh, yes, yes.
Yeah.
Yeah, I mean, it's a promise made by a professional organization. Now you can say, well, you know, is IEEE going to be around in 100 years? I mean, it was around 100 years ago, you know. So of course, nothing is absolutely guaranteed.
Of course, yeah.
But
Sure.
you know, the promise is made, and I think that kind of promise can only be made by a nonprofit organization, where that's part of the purpose of the organization.
Mm-hmm. Yeah.
Archive, for example, about 10 or 15 years ago was spun from a personal project to a nonprofit organization, so that the original architects of it, you know, felt like they could retire one day or pass on, and their creation would outlive them, for example.
Yeah.
And I think archive has been overtaken by university library. Maybe if I'm remembering right, Carnegie Mellon's library. I can't remember exactly which university's library system.
No, CMU, I think, yeah.
See, is it? Yeah. So anyway, in my lab, I would put the most efforts towards these places sponsored by IEEE, since it kind of goes along with the publication venue of the digital library.
Yeah, well, that's definitely one way to go. I think OSF has a couple of other advantages besides the long-term kind of aspect. It also has a bit of better organization, at least than ACM. So I'm mostly familiar with the ACM side of things, and there you can basically kind of put a zip file somewhere in a dark corner of the website that will somehow be attached to your paper. But that's it. And on OSF, you can actually browse through the project and view PDFs and so on. So it's just a bit nicer in terms of user interface from my point of view. So ACM is still treating this very kind of with very low priority, it seems. And ACM does have, for example, reproducibility badges by now, but Kai actually hasn't adopted them yet. So each of these special interest groups within ACM would have to separately adopt the individual reproducibility badges and artifact badges and so on. And for Kai, this just hasn't happened yet. Maybe it will at some point, but we couldn't tell. And so my impression is that ACM isn't very very interested so far in the whole topics. They kind of have the option, but it's rarely used, and it's also not very conveniently implemented, in my opinion. That's why I'm personally suggesting OSF to my students for all the supplementary material, but that might actually be different with the IEEE version.
Well, the IEEE is made to attach to IEEE publications, so you know, I hope that ACM also kind of makes those closer to their digital library, which is quite nice, you know, important resource.
Okay, I'm just looking into the chat one more time. I think there are no further questions here, so I would say let's maybe move on to the last part, wrapping up and discussing, let's say, the next steps. I think, first of all, I want to thank all the speakers and the participants who were here to the very end. So that's very nice and kind of you. I hope you had some interesting insights here. I certainly, even though I coped with the topic before, learned a lot during this workshop. And what I could say, what I would like us to do, and Ed, you already told a little bit about it in your presentation, that let's first look probably more favorable on replication efforts, however they are. Yeah, if they are strict replications or if they're conceptual replications, it doesn't really matter. You have something in your hand that you can do when you're reviewing work. You can first look favorable on those submissions, and second of all, you can actually aid replications, future replications, by requesting artifacts. Yeah, and just asking people, hey, it's not mandatory, but it would be so great if you could actually share more data for future scientists to be able to build on your work better. Other fields are doing that already, specifically regarding software, the field of machine learning, deep learning, computer vision. I mean, your paper is so much more cited and so much more picked up if you actually share your code. I think what we also learned specifically through Sven's presentation is that yeah, this conceptual replication might be the way to go due to actually problems with hardware and software, right? So hardware and software artifacts can change the outcomes of studies a big time. So we should consider, let's say, this in doing our research as well. But I don't want to talk all the time. Maybe Ed, Arifin, and Florian, you also want to say something, some concluding remarks, or some steps that we want to take further. If you don't want to, it's good enough. But I hope you don't want to say something.
I have kind of a really short comment, and I think on the one side it's encouraging to see that there are more. So even if it's just a small set of people, I think it's encouraging to see that this workshop has 15 or 20 people attending. So there are people who are interested in this topic, and I think it's actually growing more every time. And it's also interesting to see that like a slightly different community than the one I'm usually in kind of has the same issues. So therefore, I think we're kind of all in the same boat here, and whether it's ACM or IEEE or whatever else there is, no matter where you publish, it's all the same issues. And so it's probably also a good idea what Jens said. I think I fully encourage that if you review stuff, then politely ask the authors to kind of actually share a bit more than just 10 pages of written text, and maybe add a zip file or add a GitHub project, even though it's not the ideal solution still, but maybe it's a small step in the right direction, and many small steps together also kind of end up at a bigger goal, hopefully.
I have another remark. In the full version of the tutorial, which is about twice as long, or a little more than twice as long, experimentation that results in hypothesis testing is a probabilistic type of reasoning. And so if you run an experiment and get a significant result, the phenomena behind the result are not absolutely true, like in a logical sense. It's probabilistically true. And so the result of one experiment should be considered evidence for the truth of what is found. As the experiment is replicated, that evidence becomes stronger. And so another reason for replication, which we didn't really get to in this workshop, comes from the probabilistic nature of statistical inference.
I mean, this is true, Ed. The question is, I mean, what's the way out of there, right? I mean, one thing that you argued for is to basically use replication to add more evidence. You could also discuss, and maybe that's a topic for another time, yeah, to change the let's say the inference methods that we are using. Yeah, so not to rely on frequentist. Yeah, please.
Yeah, my point is that repeating empirical experiments is not just something that's kind of ethically or morally good or something like that. It's part of the way that the empirical method comes to true conclusions. So, well, okay. I'm going to sound like I'm tooting my own horn here, but on Friday, I'm giving a keynote talk in the PerCar workshop, and this is one of the things that talk will talk about. So it's on my mind.
Very good. So please also join it. I think it's a PerCar, the PerC.
Yes.
WoRXxR workshop, perceptual and cognitive issues in XR.
So we've replaced our relatively easy to pronounce acronyms with acronyms that contain an X.
Yeah, very nice. I mean
XR, and now we don't know how to say them.
WoRXxR, PerCrosser. I don't know. But anyways, it will be an interesting workshop, so please join at the 2:30
Right.
p.m. Same time as we started today.
So I've
Okay.
been thinking, because of giving this talk, I've been thinking about, like, and it's not like I'm the only one to think about this, of course. There's a large existing literature on this topic. But, you know, how do empirical experiments lead to true results? And it's a very interesting bunch of scholarship in its own right to learn about.
Okay, now I'm just looking into the round and into the chat anymore if there are more questions. This is not the case. I think Alec Moore is writing something. Maybe we wait for a minute. Other than that, again, thank you so much that you joined. And please, Sven, also share your slides. Just make them available. Maybe just use the Discord channel for publishing that, and the same for Florian and Ed and Arifin. If you want to make them accessible, you already have your links. Just paste them again into the Discord channel, and we can move on from there. Okay. So guys, thank you so much that you joined, and I would say enjoy the rest of your morning, evening, night, I don't know. And I hope that you also will enjoy the main conference to come.
Yeah,
okay?
I only wish we could now go out for dinner and beer and
yeah,
discussion.
maybe in a decade or so. Let's see.
Hopefully next year, or
yeah, let's see.
Months at VR.
Okay, great. Yeah. So then, thank you so much, and see you all around. Yeah. Bye now.
Thank you for organizing the workshop. Bye.
Let's hang on a minute.
Do you want to put the slide in?
I'm going to put it on my website. Let's see what this is about.
I think it's fine if you just for now copy it to the Discord channel. Yeah. Okay, Ed and Arifin, do we have more things to discuss? I think we are done, right?
Yeah,
I think so. Yeah, so I will put some PDFs on my website, which is where I want to kind of archive it anyway. Not that it's archived in perpetuity coming from my website.
Yeah, but it's better than nothing.
It's better than nothing, yeah.
Okay, guys, and thank you also so much for getting up early today and running that
Well,
workshop.
thank you for leading this, and I think it was very good to get more, involvement in the topic.
Yeah, and especially, I mean, I think that Sven Hoffman also brought up quite some interesting discussion points, right? I mean, why? I mean, I think that he gave a little bit of contra to our arguments, which I found actually thought-provoking and nice to think about.
Yeah, and Arifin's finding of the different kinds of replication, I never considered that, originally. So that's also quite interesting.
Yeah. Okay, guys, then I would say we probably see each other around in Town and ISMA the
I hope
coming
so.
days.
I
And
hope so.
maybe,
I
yeah,
want
we
to say
can.
I have a strong memory in 2018 of, I think it was having breakfast with you at this at our hotel, you know, a German breakfast. Anyway, that was very nice. All the way the German breakfast has all the things laid out, you know, the different meats and breads and tomatoes, always tomatoes.
Yeah, that's the right way to do it.
Yeah, just thinking, man, I wish I could have had that breakfast with you again, you know, before this.
Yeah, but there will be times.
Yeah,
Maybe not for VR, but hopefully soon enough.
I still have the money that I haven't spent in the last 2 years, the travel budget. So if it's possible to go to New Zealand, I'm going to go.
I mean, that's good. That's good. You know, I have one
Fortunately,
funding.
RFN
Yeah.
here isn't going to have the right kind of a visa to be able to leave
Yeah.
the US by the spring. So he can't go.
Yeah. Yeah, and I mean, I mean, this is a little bit ridiculous, but I have a funding actually for visiting, for my PhD student to visit other countries, and is specifically it's a travel budget, and they basically, because we weren't able to get the budget spent last year, they basically cut it off and say, no, I mean, COVID, it doesn't matter, you don't get the money for next year. This was a little bit, let's say, not so nice, but good to hear that you don't have this problem.
Well,
and maybe, yeah.
The money I'm talking about has to be spent by next August.
Okay, then you might have
Now,
a problem.
if I cannot spend it by next August, I could ask for permission for the deadline to be rolled over in another year. And I just asked for that permission this past year because it was originally going to run out in August of 2021. So they might, I mean, you know, I think they would probably allow it to be rolled over again, because saying the pandemic is a very excellent, you know, excuse.
Yeah.
But I can't guarantee that they'll keep rolling it over, you know, each year like that. I have to ask permission for every year.
Okay, Arifin, I have a short question. How is actually your current status for this sharp view deconvolution rendering? Did you continue your work on that or not yet?
Oh yeah, that's I'm continuing my work. That's on my PhD. So
that's another very interesting replication story, and that's a case where it was very, very difficult to replicate the algorithmic result. So this wasn't a human subject experiment. You know, this was an algorithm described in a paper that really could not be replicated based on what was in the paper.
Yeah, I found like 2 faults and a couple of other issues on the algorithm, and I contacted with the original authors.
And that's what did it.
That's
the original author agreed to share their original source code. And that's the only reason it got replicated.
I mean, so it's replicated because he shared, and I actually have just a single portion of code from him. And that actually the things like and they didn't provide the code or didn't provide very in describe of that portion of the implementation. So, and after that is actually worked. And though they're provided information algorithms in the I think like, should I talk here because it's actually live on YouTube and recorded?
Oh, I'm sorry. Let's meet maybe somewhere else. You're right. Oh yeah, I'm seeing that right now. Okay, I mean, let's switch over. Can we, or maybe like that, Arifin. I mean, it doesn't hurt. Maybe we can just synchronize on that another day. Maybe because I might also be interested in replicating that particular research, and maybe I can contact you just in case I have the personal resources or the man resources to do that. That would be much appreciated.
Oh, definitely.
Yeah. So let's talk about that later on.
Sure.
Okay, guys, and thank you so much again. And then let's keep in touch over this week. Okay.
All right, Jens.
Okay. Thank you. See you. Bye. Bye now.
Bye-bye.